All right, so we can now start the Mongo database, and we can play around with it, right? We can interact with it from directly using the Mongo client. But the more interesting part is interacting with it programmatically from Node.js. So let's do that. Let's go to our web storm, and let's create a couple of examples here. So under lectures, let's create here a directory where we can do some Mongo coding. Okay. So JavaScript, we'll do a JavaScript here, and we'll call this Mongo.JavaScript. All right. Okay. So we had given you already some code to play around with in the test.app.js, right? And you can actually find where this code comes from if you visit the following library. We're going to be using the following library to interact with database, to interact with MongoDB. We're going to use Mongoose. Mongoose.js is a library that allows us to interact with MongoDB programmatically from our JavaScript. Okay. There's quite a few libraries out there. And there is a native Mongo.js provided by the Mongo.js database folks, right? The ones that created the database. But it's a very low-level library. Okay, it basically allows you to interact just like we did by hand manually, right? It allows you to do the same thing, but from within a program. Okay, there is no validation. There's no higher level APIs. Whereas Mongoose provides a layer of abstraction on top of Mongo.js to provide things such as validation and integrity and schemas, creating schemas, things that we should feel comfortable coming from a SQL world, okay, which are not provided natively in the MongoDB world. Okay, so Mongoose is the library that we're going to be using. I believe we've already installed it. Let me check. In package.json. Indeed, yes, we have already installed Mongoose. If you haven't already installed it, right, you're going to need to do an npm install Mongoose, right, and don't forget to -- save, right, and that will install the library. Okay. If you come in and read some of the documents, I certainly encourage you to read some of this. It goes well beyond what we're going to be looking in class, but I think what we're going to be using here in class is going to be plenty for I would say 80% of what you would use Mongo for, but certainly has quite a few other things that we're not going to cover. So please feel free to play around with it. Okay. All right. So let's code in here in our Mongo.js. Let's copy some of the things in here. So the way it works is that we're going to need to require the Mongoose library, right? Like we've required other libraries up to this point. And once we have an instance, this gives us the API to start connecting to a database, creating a database, inserting, removing, and from within our code. So let's do that. So in our Mongo.js, right, we're going to do and load the and we're going to require Mongoose, right, and so that you don't forget, you're going to do an npm install Mongoose -- save, right. Don't forget to save. So I'm going to put here a to-do to remind you. Okay, so once we have Mongoose, we can connect to it. Now, to connect with it, you need to provide a connection string. So this string right here, is referred to as the connection string, right? And basically, this is going to tell it where in the network is the database running, right? Where in the world is your database running? The first part, like all connection strings, any network connection, typically the first part is the protocol, right? It's not HTTP. It's MongoDB has its own binary protocol and how it's going to connect to the database, and then the IP address or the location on the internet of the server where your database instance is running. By default, localhost, if it's running on your machine, then it will be localhost. The code that I gave you in your app.js should look something like this, right? We compute the connection string, right? And assume by default that it's going to be running on your local database, right? This is the connection string I gave you when you get started, and then here we have a validation, verification that if I'm running locally, I'm not going to have these environment variables, right? The mlab, username and password and host. I'm not going to have any of that. But if I'm running on Heroku or OpenShift or AWS, right, I am going to have those environment variables there, right? And if that's true, then I'm going to calculate the connection string as stipulated by those environment variables, correct? Right? The example that I'm going to give you is just connecting locally to my database. Yes? Okay. And the database name, so that's why I'm going to use localhost, right? Or 127.0.0.1. Then it's followed by the database that you want to connect to, right? Out of the box, Mongo comes with a test database that you can play around with. But I think for the first assignment, I asked you to replace this with an actual name for the database that connects to mlab. Mlab gives you the name of your database, right? And you use that instead, right? It was mlab and then some unique identifier. So for this example, we're going to connect to the. I'm going to show all the database. We're going to say show databases DBs. And we had created one for this, I think. I thought we created a summer one, didn't we? Where'd it go? Oh, maybe because I dropped the collection, it's gone. So we're gonna call it webdev underscore summer 1 2017. Right, that's the database I want to connect to. And once I'm connected to, I want to use Mongoose to talk to the database, right? But I don't want to talk to it in the raw sense, right? Not like we just did manually, right? And notice that manually it allowed me to insert two documents that had two different schemas, right? I want instead to use a little bit of higher level abstraction here that can validate for me certain things. So for instance, I like to be able to create a schema, right? And then make sure that whenever something gets inserted or updated, that it's always validated against this schema, right? So let's do that. Let's create a schema. So say it's our to-do. We're creating a to-do application, and we want a to-do schema, right? I want to make sure that all to-do items have a title and have a date, right, of the appropriate data types, right? So to do that, I can use Mongoose. Mongoose allows me to create a schema, and the schema is created by providing an object that configures the schema. So it allows you to provide the names of the fields. So for instance, I'm declaring a field of type string. Okay, string is one of the raw native data types supported by JavaScript. Okay, and also we can have a date, or maybe instead of a date, we could have like a due or due date, right, of type date. Okay, make sense? Right. So once we have that, we can now create and start interacting with it. Create a model that will allow us to interact with this, right? So to be able to interact with this, right, we need to provide an API that allows us to create instances of these objects. So to do that, Mongoose uses another level of abstraction, that the way you interact with these things, right, is through a Mongoose model, right? A Mongoose model. And to do that, we can create a model by using the model function on Mongoose. And we're going to register the model. We're going to say this is a to-do model. Now this name over here is unique, right, across the framework. Right? Once you're using Mongoose and you register this model, right, this name needs to be unique because we're going to be using it for referential integrity, right? Something that is not supported natively by MongoDB. It doesn't support this, right? And for instance, it doesn't support joins, right? It doesn't support having something referencing something else, right? Mongoose allows us to create that layer of abstraction that says, oh, here's an object that is referenced by these other objects, right? I would like to join them somehow, right? That I'm treating this as a foreign key to those over there, right? I want to join them together and retrieve data from one collection, retrieve data from some other collection, and bring me back an object that has both pieces of information, correct? So that is not natively supported by MongoDB. Mongoose allows us to provides this layer of abstraction through the use of models, okay? And to do that, you need to be able to register and say, hey, this is the abstract representation, or it's the abstract name of this thing, this objects that you are instantiating and you're storing. Right? So this is how you're going to refer to them, right, in the rest of your application as to-do model. Okay? All right, and you need to tell it what the schema is. It's a to-do schema. Right, everybody still with me? Right. All right, so now that we have the to-do model, now we can start playing around with this and start to insert things into our tables. So notice that if we go and use if we use this and we do a find here, we're going to do a show collections. Notice that there are no collections, right? Because we dropped the only collection we had. Well, we dropped it, so it's gone, right? We don't have any collections. But let's now use our little piece of code to insert data in here programmatically from here. We do to-do model, and to insert there are two functions that allow you to do that. Insert, which we looked at earlier, or there's also create, which they basically do the same thing. Now here, what they take as argument is an instance object, right? Either an object that you have previously created. My to-do one, right? You can create it here, and then pass as an argument title pick up milk and due date today. So we can say maybe a new date. Okay, and then you can insert it, pass it around as an argument, right? Or you can just embed it here. Right, and it could be an anonymous object that you insert and then it just throws away. But let's do it this way to do one. So if we run this, let's see, we can run it from the terminal. And can we make this a little bigger? No, we can't. Maybe we can run it from the command line. Let's do that. Where are we? Let's see. We need to go into NEU. Oops. NEU, what do we have here? 2017 maybe? No, that doesn't sound right. Oh, maybe webdev probably. Yeah, exactly. Then 2017. Yep, 17. Then it's summer 1. And then we have, what directory are we in? WebDev summer 1 WebDev. Yeah, CD WebDev. All right, so I think we're in the right directory. Let's go into lectures, and in here we have undergraduates, and there we go. There's our Mongo. There's our Mongo.js, right? This is the library that we're looking at. Let me just make sure. Yeah, that's where we are, and let's run it right from the command line. Let's run it. So we're going to say node. And just Mongo.js. It runs. let's see. Did it work? Let's see. Show collections. All right, so it did insert, right? Notice that it created it, and notice the name that it chose for the collection. See that? It says to do models. Right? I didn't use the S at the end. No, actually, I never told it what the name of the collection to use. Right? So it made a best guess, right, of what name of the collection to use, and it based it on the name that I gave it, the name of the model that I gave it. Okay, and it tries to do its best to pluralize this, right? And notice that it added an S at the end. Okay, and I'm sure I've mentioned here my disdain for pluralization, and especially I don't like it to choose its own names on its own. So I prefer to choose my own names instead of it arbitrarily choosing this name for me. But nevertheless, let's see what it did create to do models, and we can say find, and there it is. So we have the title, pick up milk, and notice that the due date is of type ISO date. Indeed, I believe that is today's date. Okay. Yes.
So a model is equivalent to a collection. And what?
A model from a Mongoose, right, allows you to interact with a collection, allows you to insert into a collection, remove from a collection. But it carries the name of that collection. Yes. Yep. All right, so I don't like it choosing the names of the collection. So instead, you can explicitly tell the schema, right, what the name of the collection you want it to use, right? So you can provide. Notice that after you declare the schema, after you tell it the JSON object of the data types that you want in there and the attributes, you can give it a configuration object. Right, of which one of the things that you can configure is the actual name of the collection that you want. Right, so you can say collection, right, and then you can then say that I want it to be called to do, right, and I don't like pluralization, so I'll choose this singular name. All right, so if I run this again, not here, I run this again. If we go back and do a find again, notice that we still have that one, but if we list the collections, now that we have two, right? The one we had created earlier, right, where it arbitrarily chose that name, and then this one that we just created in there. Right, so we can do find from my to do, and find there it is, pick up the milk. Everybody okay? You still with me? All right. Notice that this. When we ran it, notice that it kind of like blocks. See that? It's kind of like waiting for me to do something, right? And that's because all these functions they have two versions. You can treat it in two different ways, right? You can treat it in a they're both asynchronous, right? All communication to the database is going to be asynchronous. So this Mongo.js running on Node.js is talking to another server, right? That is running on Mongo, right? That could, live halfway across the world, right? All these functions allow you to handle this asynchronous communication, right? One of the ways that it can handle it is by you can provide a function that can be called back and notify you of what happened. Did it work? Right? If there's any status information, and this function has the signature of providing the first argument is an error, right? And if nothing went wrong, then that error is just plain old null, right? And the second argument is the actual document instance that was inserted into a database. Right? So this is kind of like an acknowledgement. Here is the object that was inserted. This object does have the underscore ID, right, that you didn't have when you pass it to me, right? And we can check for an error. If there is an error, then maybe we can do console error. Otherwise, we can just print out console log and print out the doc. All right. So we can do that. Let's run this again. So we run it again. Notice that it comes back with the object. There's the title. That's the due date that you asked for me. And also notice the underscore ID. Okay, that's the ID that we didn't have, but it was inserted for us. Notice these other underscore thingies in there, right? Those are for internal purposes, for Mongoose to do its own cleanup, and make sure that these objects are in sync in RAM, and also they're in sync in the database. Okay, everyone okay? All right. The other way to handle this is that instead of using this function, you can instead use promises. You can use then, right? Just like we've been doing before, right? We can do then, and you get the two functions. Either this is the successful function, right? And you get here the document. This is the raw document that comes from the server. It's not wrapped, okay, like we had on the client side. This is the raw object coming from the database server. Or here we have the error if there's an error coming from the database. Yes? All right. If we do that, and we run it again, I think I'm using an older deprecated library for the promises. Although I think it did insert it anyway. Let me see. Do I find? Oh, we've been inserting a whole bunch of them, right? Anyway, you'll see this error we're using a deprecated promise library. So Mongoose out of the box uses a deprecated library, promise library, but you can provide your own library. There is a library they're going to be using in this class. It's called the Q library. There's a couple of promise library that can be used. $Q is the one that typically you use from the Node.js library. You can install it. Maybe we did already. Let me check. If you're going to your package.json, we have not installed the Q library. Let me see. Node.js, Q promise library. And I think we can just install it using npm install. I think it's just called Q. Let me install it. So if here from the command line, where are we? Let's see. Are we in the right place? No, let's go up one. Up one. Am I in the right place? Yes. We can install it here. We can say npm install Q. And don't forget the -- save. So this is a very common library. Okay. Then we can require it. Notice that it added it here as a dependency. And from our example, we can require it by just saying require var q equal require q. Okay. And one common thing to do is to tell Mongoose, hey Mongoose, don't use your deprecated promise library. I'm getting all these errors. Instead, use this brand new, up-to-date library for all your promises. Okay. And I don't remember how do you do that? Let me see. Let me see if I can find it real quick. Mongoose JS promise global. Do we have the global? Mongoose async promise backwards compatible Chris. Okay, let me see. New Mongoose promise. There we go. Bluebird Q. There we go. Right. Okay, so we're gonna have that same require. We're gonna have that same require. There it is. There's the require Q. Right. There's our require Q. But we only want just a promise object. And then we're saying execute, etc. Wait. Mongoose promise. Mongoose promise. That's all I need. We're telling Mongoose, hey Mongoose, don't use your deprecated promise library. Instead, use this brand new require. All right, let's try that again. And we had, I think we moved to the wrong directory. So let's see, we were, where is it? Under lectures, undergrads, Mongo, and we can run Mongo.js again. Oh, promise. Promise, require queue. Oh, thank you. It's down here, thank you. Okay. Oh, we never did anything here. So it's it worked, but let's see. Let's do a console log. Right, here's the document that we got in there, or the error. Error. So let's run that again. There we go. Right, so that's the object that we are inserting, right? And we're back where we were before. So now you can use it either way. Right, you can either use it using the promises library, right, which is where we're going to be, what we're going to be doing for the rest of the semester, or you can use the other the callback function. Now, if you use the callback function, it's going to work fine either way, right? The problem with using the callback function is that if you have many queries nested inside of another, where you have to query an object or collection, and then you have to query another collection inside. Once you get a response from the first query, you're going to end up with code that is it looks very nested, nested inside of nested, callbacks within callbacks within callbacks within callbacks, right? And it's just gonna look funny, right? So that's actually one of the main drivers of using promise libraries, is that instead of having all these nested callbacks, you end up with code that looks as if it's sequential, even though it's asynchronous. Okay, looks as if it's synchronous as opposed to even though it's asynchronous. All right. Okay. So let's see. We've inserted a few things. Let me comment that out. Let's now query from the database. Right. We've inserted a whole bunch of to-dos. We can retrieve them. So let's comment that out too. Let's retrieve from the same to-do model. We can say to-do model dot find. Okay, and this is the dot find that looks very, very similar to the dot find we did manually, right, when we were using Mongo, and we can then see what comes back. Right, here's the function. Instead of being just one document, presumably it's a plural, right? It's several documents. So what you're going to get back, it's an array of documents, right? So we can do a console log docs. Okay, so if we run that again, there they are, right? So it's an array of objects, right? Each one with its own primary key. The titles, they're the same title just because we've been inserting a whole bunch of them in there. You can also, instead of retrieving a collection of them, you can retrieve several of them. Ideally, you would have these in functions, right? You would have maybe, instead of a function, something like find all, right? Find all to-dos, and you have this like that, right? And typically this would be a return. So somebody, right, is going to call this, right? And what they're going to get back is a promise, right? And they're gonna have the then, right? You're gonna have the then. So let's do that. It'll be something like this. We will return the find, and somebody who wants to use this would do something like find all to-dos, but what they get back is a promise, right? So that they can receive the to-dos here, to-dos, and we can then print them out, right? You can say console log to-dos. Yes, right? So this is how it would work, right? It works exactly the same way. Everybody okay? Right. Same thing. Our create, right? Our create. Typically, we would embed this inside of a function, function create to do, and it would receive a to do object, right? And what they would get back is a promise, right? Where we have here the to do, and this would live outside, right? Somebody who calls this, right, would be able to call, find, create to do, right? And you can pass it an object saying that the title is upload videos, right? And the date is new date, right? And once that happens, we can have a then clause that receives the brand new document or the brand new to-do that was just added, right? And then we can console display that. Console log to do. Make sense? Right. So let's run that. All right. So we inserted that new one, but notice it's not in the Finder. See that? It's not in the find. It's not in the find. We would have expected to see upload videos here, and it's not there. Right. And the reason is that, again, these two are asynchronous, right? This is gonna be, shot and it's gonna be handled by one thread, right? And this is gonna be handled by yet another thread. Okay. So our single thread that is running through this, okay, it's not going to block waiting for this create to do to come back, correct? Right. So it's just gonna ask the operating system, hey, operating system, can you handle this? And notify me when you're done. Right, and then it's just going to go on to the next function call. See that? It's going to call the find all to dos, and again, it's going to start a new thread. The operating system is going to ask the operating system to handle this asynchronous call. Right, you handle this, and when you come back, notify me. Okay, so it could be that what happens here is that we have a race condition. Right, we have two threads that are not guaranteed to execute in any particular order, right? It might be, or it seems to be, that this operation is completing before the create has been completed. See that? Right. So there's no guarantee that one is going to do before the other. We might have expected it, from our von Neumann, sequential reading of our code from top to bottom, from left to right. We would have expected that the create would happen first, and the query would have happened second, but it's not. If you want to guarantee sequential query, you have to embed these two things, right? We have to embed them. That's the only way to make sure that this will occur after the create, right? We have the then. This tells me that there's a callback telling me yes, the create has happened. Okay. Now it is guaranteed that document is in the database. You can now go on and do the find. Yes? Right? So if we run this again, notice that indeed we have the two upload videos, right? One that we had before, and here's our second one that we called it, right? But they're both in there. Just to make sure. Here's another to do. Share lecture code. Okay, and let's run this. Notice that sharing the lecture code is indeed there, right? It was guaranteed to be there after the insert. Then we can query it, and it is there. Make sense? Right? Now, the whole point, notice that if you're using callback functions, notice that your code is going to progressively look slanted, right? Because you have these nested within nesting, right? And that's the whole point of using promises, right? That this allows you to, instead of putting the then here, right, it allows you to do a return here, right, and move this then move this then here, right? And so if you run this again, notice that it behaves exactly the same way, right? We have two shared codes, right? So it looks like it's synchronous, right? One thing after another, even though, right, each individual one is asynchronous. Make sense? Right, this was one of the main drivers of creating this type of abstraction. Okay, that basically the then function is only a register function, right? It says here's a function, here's a callback, right? Call me back on this, right? But it's just a syntax allows you to write it in such a way that it looks synchronous even though they're asynchronous. All right, so here that's the create, and we do the find. We can comment that out. No, can we comment the whole thing out? So we have find. Yes.
So when in the promises, like the function that you're like when you're querying the database, that return object, like the to-dos, is that just like a regular JavaScript object? Like
yeah, it is. Yep.
Like,
Yep. So we have find all to-dos, create to-dos, and what we're going to do here is that on the to-do model, right? We're going to not only do we have the raw create, find, update, remove. Those are all the raw methods that are generic, right? That allow us to talk to anything in Mongoose. We're also going to tie here our high-level functions, such as find all to-dos, right? So these are specific to our data model. Yes, this is us wrapping, right, our low-level interaction with Mongoose. We're wrapping it with a high-level API, right? That is declared we're creating an abstraction layer, right? That lets us think about to-dos as opposed to thinking about Mongoose models. Yes, and that's very common in all languages. Even in Java and .NET, typically we create a data access layer, right? Or sometimes referred to as a DAO, right? A data access object, right? That hides all the low-level data access, right, into a nice API that allows you to think in terms of this higher level API. So to-do model dot create, right? And what we're going to do is that we're going to export. We're going to say modules dot export to-do model. We're going to export. So anybody who requires this file. Anybody who requires this file is now going to be able to use this high-level API, right, and actually interact with the database, right? And what this API allows you to do is it hides the fact that we are using Mongoose, right? If tomorrow you want to change the implementation to use Postgre or MySQL, or you want to use relational databases instead, right? That's okay, right? Your higher-level application layer, right, is going to use this high-level API, right? And underneath, you're free to change the implementation, right? To use some other database, right? Later on, we're going to play around with Postgre, right? And replace the data model with Postgre instead, which is a SQL. It's a popular SQL database that also provides NoSQL features as well. So this is a good practice, right, to provide a high-level API for your particular data model. And so today we looked at being able to create, being able to find all to-dos, and in the next lecture we'll provide other finder methods. I would like to be able to find to-dos by title, by genre, by dates, by who's assigned it to it, right? Also find a particular one by ID. Also, I'd like to be able to remove or update a to-do list, right? And we'll do that in the next lecture. All right? All right, thank you.